Take a minute, read it, see if you can come up with the formula you need, take the derivative of the formula, and write down everything that you know. Pause me. All right, so this is what I have. I hope you have the same thing. And so I'm just going to start plugging numbers in and see what I end up with. So I know dAdt is 6. And then I've got 2 pi. They didn't give me the radius. But they clearly, if you look right here, they're asking for how fast the radius is increasing. So they definitely want to know dr dt. Like, it clearly states that in the problem. So the problem is that this is what I'm looking for, but they didn't give me the radius. But they did give me this little bit of information down here, which isn't anywhere here. Like, I don't have a 9 anywhere here. And there's a reason why they told you that the area, if you read it right here, the area is 9. Now, they're talking about the area of the circle. So we did this yesterday where there was one question where they didn't give us the radius. Remember, it was the ripple, and the radius was increasing, though, at a rate of, I think it was like 3 feet per second or whatever. So we multiplied 3 times 10, and we got 30. So this is kind of similar to that. So what I'm going to do is I'm going to just do a little detour here. I know that the area of a circle, its formula is pi r squared, okay? And they just told us right here that the area is 9. So I'm going to put 9 in there, okay? So I have 9 equals pi r squared. Now hopefully you can see with a little bit of algebra, we can find the radius. And then once we get the radius here, we're just going to plug it right in here, and then voila, we're kind of done-ish. Okay, so let's keep going. Well, to get the r by itself, I would have to divide out the pi first, so I'm going to do that. So that's 9 over pi equals r squared. Okay, now I need to get the r by itself even more, so I have to get rid of that square. So I'm going to square root both sides. Okay, and then that is going to give me r equals, well, the square root of 9 is 3, but I don't know what the square root of pi is, so I'm just going to leave it like that. Who cares? And there's your radius. It's ugly, but it's right. Okay, so let's just throw that in there. 3 over radical pi. Okay, now I understand that's ugly, but we're just going to be very careful here. So we're going to have 6 equals. We are going to multiply 2 pi times 3, because remember, technically, here, let me write this for you. This is over 1. So when we multiply, we're just going to multiply numerators with numerators, denominator with denominator. Okay, don't worry about the ugly factor. That's okay. So we're going to get 6 pi over radical pi, and then times dr dt. Okay, now if we want to get rid of this, I could divide it. That's kind of like baby math. Really what we're going to do is, remember, keep, change, flip. So I'm going to multiply this and this by the reciprocal, and that will get rid of it on this side. Okay, so let me rewrite this. So I'm going to have 6 times, let me put this in a different color so you can kind of see it. I am flipping that fraction. See what I'm doing? Okay. And that equals dr dt. Okay, so I basically multiplied both sides by this, and then I did it over here. I'm going to try to squeeze it in. Radical pi over 6 pi. Okay, so that's how I got from here to here. Okay, now while I'm at it, I am going to just show you that I can cancel out these 6's. So then my dr dt is equal to radical pi over pi, and that would be miles per hour. And there's your answer. You don't need to make it a decimal or anything like that. Good morning, everybody. I would like you to take out your notes packet and you're going to open to page 4. Okay, we are actually going to skip number 5 for right now. We will go back to it. I'd like you to make sure that you're taking notes as I go through each question, so make sure you have notes in your notes packet. Okay, so we're going to look at number 6. All right, so a spherical balloon is being inflated so that the volume is increasing at a rate of 8 feet cubed per minute. How fast is the radius of the balloon increasing when the diameter is 2 feet? Okay, so they're talking about a spherical balloon, so you can look up on the board and you can see the formula for the volume of a sphere. Okay, so let's start with that. So we know that the volume formula is volume equals 4/3 pi r cubed. And because they're talking about things increasing, then we know that we're going to be taking the derivative. So let's take the derivative of this. So we have dv dt equals, okay, and remember that we are going to be taking the derivative, so we're going to take this 3, and we're going to put it in front and multiply it by the 4/3, which means that this 3 and this 3 will cancel each other out, right? Because we're doing 4/3 times 3 over 1, which is just going to be 4. So we've got 4 pi r squared and then dr dt. Okay, so let's take a minute and let's write down the things that they gave us, or the things that they're asking us to find. Okay, so let's read the first sentence that we have here. It says that the balloon is being inflated so that the volume is increasing at a rate of 8 feet cubed per minute. So knowing that, then we know that that is dv. Oops, that's a v. dv dt. And it's increasing, so that would be a positive 8. The next thing that they're giving us in the next sentence is how fast is the radius increasing. So how fast is the radius increasing? That would be your dr dt, okay? And we don't know it. They want to know what dr dt is, so we're going to put a question mark there. And then the last fact that they give us is when the diameter is 2 feet. Well, now, let's think about this for a second, because if we go back and we look at this formula, we don't have a diameter in there, but you should know the ratio between a diameter and a radius. So if the diameter is 2, that means the radius is 1, right? Okay, so now let's plug everything in that we know. So we're going to go 8 equals, make sure you're writing this down in your notes packet, 4 pi, this is going to be 1 squared, and then dr dt. Okay, so we're going to divide both sides here by 4 pi, right? Because 4 pi times 1 squared is just 4 pi. And that's going to cancel all of this out. And then I'm just going to simplify the other side. Now, just be careful. Make sure that that pi stays in the denominator. Okay, so 8 divided by 4 is 2, but the pi has to stay in the denominator with the 4. Okay, even though 4 gets canceled out. Now, we are talking about dr dt, so the units would be feet per minute. And that would be your dr dt. Okay, why don't you take a minute, read number 7, and see if you could set it up and maybe even do the whole thing. So pause me, try it out, and then come back. Okay, so like number 6, we're going to be using the volume of a sphere formula, and there is the derivative. Let's look at everything that they gave us, or talked about anyway. Okay, so they said the spherical balloon is being deflated, so let's be careful of that. That's going to insinuate that we have some negatives here. So that the volume is decreasing at a rate of 3 feet per minute. Okay, all right, so that is basically giving you dv dt. So we have dv dt equals, but let's be careful, that should be a -3. Okay, all right, the next thing that they gave us is, or ask for, how fast is the diameter of the balloon decreasing when the radius is 2 feet. All right, so we got a couple things going on there. We know that the radius is 2, and they want how fast the diameter is decreasing. So really what they want, I'm going to use a capital D for diameter, just because I've got a lowercase d right in front of it. So this is really what they want. All right, now you might be like, well, wait a minute, we haven't done anything like that, and you are right. But what I'm going to tell you is we just need to find dr dt. Because let's think about this. If I can find dr dt, right, I don't know what that is, let's just say. Well, let's just say we really don't know what it is. But if I find this, all I have to do is double it, and I will get this, because the ratio between a radius and a diameter is 1 to 2, right? The diameter is double the radius, so if I find this, all I have to do is double it, and I will get the answer to the question. Okay, so it's not really all that bad. All right, so let's see. So we have a -3 here, and then 4 pi, the radius I know is 2 squared, and for the moment we're going to find dr dt. All right, so that's going to give me -3 equals, let's see, 2 squared is 4, and 4 times 4 is 16 pi dr dt, and then I'm just going to divide out that 16 pi. Okay, so my dr dt is equal to -3 over 16 pi. Now, I want dt, the rate of change of the diameter. So all we do is we take this and we simply multiply it, that's multiply, by 2 over 1. Okay, so then we are going to get for our dt, that will be -6 over 16 pi. Oops. Now if you want to reduce that, 2 goes into both of those, so -3 over 8 pi, and it would be feet per minute. Feet per minute. Okay, so not a big deal. All we have to do is just double, and we're good to go. Okay, again, please make sure that you're taking notes in your packet. Now, what I'd actually like you to do is, let's go back to number 5. There is a reason why I skipped that one, so backtrack. Let's go to number 5. Alrighty, let's drop down to number 8. So why don't you take a minute, read that, pick a formula, find its derivative, and write down everything that they gave you. Pause me. Alrighty, so, well, we use this same exact formula on number 6 and 7, so this should not really be anything new to you. dv dt is 100 because it says that the volume is increasing at a rate of 100, so that's dv dt. They want to know how fast the radius is increasing, so that's dr dt. They gave you that the diameter is 50, so just remember, the diameter is 50, then we know that the radius is 25 because that's a 1 to 2 ratio. Okay, all right, so let's just throw this in. So we have 100 equals 4 pi. The radius is 25, we're going to square that. And then dr dt. Okay, so we can throw the 4 times 25 squared into your calculator, and you should have gotten 2500 pi dr dt. Okay, so I'm going to divide out that 2500. So when I do that, I am going to do 100 over 2500, throw that in my calculator, and that will be 1 over 25. Please make sure that that pi is in the denominator because I am dividing by 2500 pi, so that pi stays in the denominator. Okay, and then we are going to have meters per second. And there is your answer. Alrighty, again, please just make sure that you're taking notes in your notes packet. Okay, so let's look at the last one that we're going to do today, which is number. All right, so again, why don't you pause me, come up with a formula, look up on the board. This one we haven't used. Write everything down on the right-hand side and see if you can solve it. Okay, so this is the information that we have. I just, by the way, when I took the derivative of the surface area, I wrote dSA dt, so that we knew that that referred to the surface area, not just area itself. Now, just a couple of things. Notice that the surface area is decreasing, so make sure that you have a negative there. Okay, and so let's see what we have got here. I'm going to put in a negative 0.5 here, equals 8 pi times 4 times dr dt. I am going to divide all of this by, what is that, 32 pi? And the rest I'm going to put in my calculator, but again, leave the pi, just do negative 0.5 divided by 32. And so my dr dt ends up being a negative 1 over 64 pi. And what are our units? We've got centimeters per minute. And there we go. Okay, so guys, again, just make sure that you took notes in your notes packet. You're going to have a quiz on Friday. So when I come back tomorrow, we are going to go through a little bit more in the packet. And we're probably just honestly going to be working on, let's say, 10, 11, 12. And that's just one concept. So like today, we did a lot of volume with spheres. And the day before, we did volume with, what did we do the day before? On numbers 1 through 4, we did circles and we did squares, right? So your quiz is going to be on the circles, squares, spheres, and then what we do tomorrow, okay? And then you'll have a little quiz on Friday, okay? I know we have shortened periods, so it'll be a little quiz so that you have plenty of time to finish it, okay?